The last type of stoichiometry we're going to look at is solution stoichiometry. And these are calculations that involve volumes and concentrations of solutions. All three types of stoichiometry that we've looked at can be combined together and quite often are. So the mass of a substance might eventually lead to the concentration of a different substance, or possibly the volume of a gas might go back to the precipitate and a mass of that reaction. So be prepared to combine these together. In the first example we're going to look at for solution stoichiometry, we have 200 milliliters of 0.503 mole per liter solution of ammonium carbonate that's mixed with excess aluminum chloride solution. And so we're going to determine the mass of the precipitate that forms. So just like always, we need to start with a balanced equation. So the ammonium carbonate, NH4,2CO3, and that's with an aluminum chloride solution, AlCl3. And on the product side, we will have ammonium chloride, NH4Cl, and second compound, Al2CO3, 3. And checking your solubility table, you should see that the ammonium chloride is soluble and the aluminum carbonate is the solid. That's the precipitate. So balancing, we're going to need a 3 and a 2 on the reactant side and a 6 and a 1 on the product side. We know the concentration and volume of the ammonium carbonate solution, so let's write those down. And we know that we're finding the mass of the solid that formed on the product side. I'm going to show you a way to do your calculations all in one long line as opposed to breaking it up into 3 separate calculations and answers. We're still going to be following the same steps. We're just not going to write down an answer at all of the in-between points. So by the end of my calculation, I will have the mass of the aluminum carbonate. So for the calculation steps, first thing we want to do is find the moles of our known substance. That's the ammonium carbonate. I have moles per liter and milliliters. So that means I want to multiply together 0.503 moles per liter. And I'm going to change the volume into liters so that I know my volumes cancel and I've got moles. So this is giving me moles of the known substance. Next step is to multiply by the mole ratio. So the moles of what I want go on the top, and that's the aluminum carbonate, and cancel that with the moles of the substance I've already worked with, and that's the ammonium carbonate. So that means the ratio is 1/3. So now I've canceled the moles of the ammonium carbonate. I have moles of aluminum carbonate. So last thing is to find what I need, and that was a mass. So now I want grams over moles. And the molar mass for this is 233.99. Moles are canceling, and now I have grams, and the answer comes out to 7.85 for the 3 significant digits in the question. In the next example, we have 500 milliliters of 0.1 mole per liter solution of sodium hydroxide, and that's neutralized with 0.273 mole per liter solution of sulfuric acid. Now I want to determine the volume of sulfuric acid that's used. So again, we're going to do this in just one big long calculation, and that means I need to start with a balanced equation. NaOH, my first solution, gets combined with sulfuric acid, H2SO4, and the products are sodium sulfate, and that's soluble, and water. And sometimes it's helpful to write water as HOH, just for balancing so that you can see all the different ions or atoms as they move around in the reaction. For this, for balancing, I want a 2 for the sodium hydroxide, 1 acid, 1 of the sodium sulfate, and 2 water to balance properly. The concentration of the sodium hydroxide is 0.1, and the volume is 500 milliliters. Sulfuric acid concentration is 0.273. And the volume is our unknown that we're going to be solving for. So again, I'm going to do one big long calculation, and that means that by the end, I should have volume of H2SO4. So starting with my known, which is the sodium hydroxide, I need moles, so that means I'm going to multiply together the moles per liter, the 0.1, and the volume. And in this case, I'm going to show you where, again, just like in the gas lesson, we can leave that prefix on. So by doing this calculation, my liters will cancel. The milli is still there, but I have moles of my known. So I've finished step 2. Now I can move on to step 3, the mole ratio step. Moles of my unknown, H2SO4, go on the top. Moles of what I know, NaOH, go on the bottom. So now my ratio is 1/2, and I've canceled the moles of sodium hydroxide. So at this point in the calculation, if I worked out an answer, I would have millimoles of sulfuric acid. I need the volume, so I've got one more calculation. Volume is measured in liters, so using the concentration of sulfuric acid, which should be moles per liter, I'm going to want liters on the top and moles on the bottom so that they cancel with the moles from the previous ratio. So 0.273 moles per liter goes in, and now moles are canceling, and I'm left with liters and the prefix of the milli that was back further in the calculation. So the calculation comes out to 91.6, and the units for that are milliliters. So remember, in some of your calculations, you can leave those prefixes and see if it works out with your answer in a unit that makes sense. If not, go back and convert that so that you know that all of the things are going to cancel that you want to.